Good afternoon. It has been a long day for you, I think. Now here, this is the work mostly done by Donhyug Kang, and I partly involved in it. And we approached for the red tide issue a little differently. We focus on how to detect in real time, not for the why it occurs or how to eliminate this one. So we approached how to detect it in real time as soon as possible. So we developed the acoustic sensor to detect this red tide. From the previous talk, you hear the damage of fish by this red tide. That's why it is called a harmful algal bloom. And the occurrence of this red tide becomes expanded to around the world, many regions. And monitoring and detecting HABs has been done by direct capture and also observing those cells under the microscope. These days you can use like flow cam or the others. But still, capturing method needs time and money, the labor, and also you cannot cover space, a large space, and also you have the restriction in the time of detection. I mean, you cannot do this kind of detection during the night. Also, satellite, it can monitor large area, but satellite can detect only at high density. So at low cell density, it's not easy to detect by satellite. So the objective of this study was to detect rapidly at low density and also real time, and also we can control the sensor from the remote place. So we developed real-time detection system based on acoustic method. So first, we did experiment in the lab. So the one occurs in Korean waters is the Cochlodinium. This is the species that cause the red tide almost every year. So we used this one and we cultured it, and then with varying cell density, we measured the scattering, sound scattering. So difference in backscattering strength. So using 3.5 megahertz, we measured almost direct correlation, very good correlation between the cell number and then the acoustic signal. So using this lab experiment, now we were confident about this acoustic method. And then this is the overview of the acoustic detection system. So sensor is here. Here is acoustic system here. And then network and relay server system is here. And then by CDMA, the communication network, we receive the signal from the sensor to the lab. Also, we can control this sensor by this communication network. And we developed two systems, a buoy type system and also a towing type sensor. But the basic principle is the same now in both buoy and then towing type. So this is the system scheme. So here acoustic sensors and pulsar and receiver, and also envelope detector, and then signal processing and control. And then using CDMA communication network, it can go to the lab. Okay, this is the real field photographs, how we mount it and then how to test it in the field. So we made the prototype, and then we went through optimization, and then now we have a very small sensor. So this is the V type, and then this one is the towing type. And then we make this sensor much smaller. So now we have about 30 centimeter long and then 15 centimeter in diameter. So very small sensor we can use. And remote control, the CDMA network, and then multi-V control and real-time monitoring. And you saw this figure during the lunchtime in the recession room. So in real time, we receive the signal from the field, and then we now display it in the recession room. Now we are here is the scene, and then we have two sites. In fact, three. Here is two sites here. So here 1 and 2, 3. So we operating 3 sites. If I go a little detail about how well it works, and then how it works, and this is the test in 2013 in the field. At that time, cochlodinium bloom occurred, and then it started. We start measuring June 29, and at the beginning there was no red tide, and also the signal was low, and then it start to increase, and then you see this signal up here, and then the high density of red tide occurred, and so yeah, here you can see now the precaution level and then warning level. July 14, 2013, we detected. This sensor detection was predated 1 or 2 weeks predated from the manual detection by capturing and observation. And also this one shows that the diurnal difference of the red tide occurrence. So during the daytime, the high red tide density detected, and then at night, low density is detected. So we can see the high and low density during daytime and night time. Yes, so this is the repeated appearance of this cycle. Yeah, and then this is the acoustic measurement, and then the real sampling data, and we compared this one with a diatom. So this is the red tide species, and then whether this sensor distinguish diatom and red tide species. And here, when there is a diatom, but we don't see a high signal. So we were certain that this sensor can distinguish red tide species, cochlodinium, and then diatom. And since this is the real time, it can detect a very short time of high density appearance. So intermittently appeared at daytime, high red tide. Since the fish kill damage occurs when there is high tide, high density of red tide, but that can last very short time. So, like for example, 2 hours or 3 hours of very high density of red tide may kill fish. So the detection of the high density of red tide should be done within very short interval. So this sensor is very good because it is a real-time detection, but the manual capturing or the other method is not easy to detect very short time occurrence of high density. And also it isn't mentioned here, but it is very useful for detection of the red tide during the night time. Since nighttime, people cannot go into the sea and monitor the occurrence. But since this is the real time, it is very useful. In Korea, mostly the fish kills occur during the night time. During the daytime, the fishermen are alert, so they keep monitoring how the red tide comes to their the fishing net, the aquaculture net. So once they see it by eye, the red color, they do some kind of measures like spraying the clay. But at night they cannot do it. So fish kills occurs mostly at night. So this kind of sensor is very effective in detecting a nighttime occurrence of high density red tide. Yes, this is a tow type acoustic system, and yes, with this towing type, we did the field experiment how it reflects the red tide intensity. So when there is no red tide in here, the signal remains just low. But when there was red tide, signal appears higher. So the towing type, the sensor works well by doing experiment. So if I summarize the talk, in order to rapidly detect red tide, acoustic system was developed, and then 2 types, buoy type system and then towing type system. And then the sensor can be controlled in remote distance. So from the lab or this monitoring center, we can control the sensors. And then the sensor shows very good correlation between the acoustic data and then in the field, the sampling data. So there is good correlation. And then it can be used as a good tool to early monitoring and then manage the red tide. Thank you very much.
Thank you very much for your talk. If you have a question, please raise your hands. Okay.
Thank you very much for the informative presentation. It seems that your acoustic system to detect your red tide, specifically for Coclodinium, can detect diatom and dinoflagellate species. But then have you tried it to test whether other dinoflagellate species can be detected, meaning the non-harmful ones?
This sensor use 3.5 megahertz or 5 megahertz. So the frequency is important. And then it can distinguish diatom from the others. So here. Yes, a diatom, when there is high density of diatom, but signal was low. But for other dinoflagellate, we didn't do that experiment. We did cochlodinium, since we need to culture the species and then do some lab experiment with varying density. So at the least, we know it works for cochlodinium, but probably it will work for other dinoflagellate too.
So may I follow up, please? If it is all right with KIOST, may we test this with pyridinium and some of our cultures? We have a lot of them, to see whether this would work with harmful and non-harmful tropical species. Well, anyway, cochlodinium is cosmopolitan, but anyway, pyridinium would be a very important specimen for further studies. Thank you.
Thank you very much. Any questions? Okay, thanks.